Let's start thinking about multiplying these complex numbers together. Maybe dividing these complex numbers, but in the trigonometric form. This will be a fun one. You're going to appreciate this. I say with sarcasm. All right, so I got it written up. Let's say we have one complex number. We got another complex number. It's all generaled out with variables and not really any numbers. And we want to know, hey, what are we going to get when we multiply those two suckers together? Now, your text has everything written up as theta 1s and theta 2s, R1s and R2s. I'll leave the R1 and the R2, but I'm going to change something. I'm going to change the theta 1s, and let's call this alpha. And let's take the theta 2s, and let's call these beta. So like alphas and betas, we've seen those pictures. It'll be easier for us to follow along. So we want to know what they are? Well, let's do it. I'm going to do this in a general form so you don't have to. So let's take our first one. R1 cosine of alpha plus I sine of alpha times our R2 times cosine of that beta plus the I sine of, of beta. Now we can take the R1s and the R2s and we just set them next to each other. All right, so whatever your modulus is, or your distance to the origin, or the radius, you just put the radii together and you just multiply them. But what we're going to have to do, and this is where the fun is going to be, and you're probably rolling your eyes right now, is we're going to need to FOIL this out. And then we're going to see something that's quite convenient. It's going to happen, so move it down and get some more room. All right, so the R1 and the R2, that's just going to stay there. But here we are. So cosine alpha times cosine of beta. Get a little more room in here. All right, and then we go to here, and we multiply that through, so we're going to get an I times, what's that? Cosine alpha sine beta. And next, we're going to come in here. We'll have I sine alpha cosine beta. And then lastly, we're going to have the I times I. I times I is going to change that positive to a negative right here. Okay, so that's why we're going to get a negative. I times I is negative 1. It's going to change the sign. And now we're going to have sine alpha sine beta. Fun stuff, huh? Now what I want to do is I want to take everything that doesn't have an I and put it next to each other. And everything with an I, I'm going to put that next to each other. So I'm just going to put what's in pink up front, what's with blue out back. So we're going to have cosine alpha cosine beta minus sine alpha sine beta. Cosine, sine, weird. Plus, and I'm going to cheat. I'm going to use this I here first. So cosine alpha sine. Actually, I'm also going to do something else with this. I'm going to turn these two around. It doesn't need to be turned around, but I'm just going to write it backwards. So we're going to say I times sine alpha cosine beta plus I times cosine alpha sine beta. And then I'm going to cheat a little bit here, if you don't mind. I'm just going to take this I and just factor it out to the front. So here it is. We have cosine minus sine. And then we have sine, cosine, sine. I swear we've heard these chants before. I swear we've heard them before. So what this actually is we say R1, R2, that this first is going to be cosine of, this is alpha plus beta. Cosine, sine with a negative in the center of it is going to create the cosines addition formula. And then over here, we're going to have that this is sine's sum formula. Sine, cosine, sine. Sine keeps the same sign. There it is. Alpha plus beta. And there's our formula. There we have it. What it's saying is that if you multiply two complex numbers together in trigonometric form, all that's going to end up happening is you multiply your radii together, and then you add your angles. It's kind of like you're doing exponent rules. So let's write it in our our nice and pretty way that our text might want to. Oh, no, don't need to do that. I brought it along. And here it is. For our Z1 and our Z2, if we are to multiply them together, it says just take the radii and multiply those. And then inside the parenthesis, all we need to do is add our angles. Add them. So when you multiply, you think the angles get added and the radii gets multiplied together. And of course, we also have a division. So if you have them being divided, we will take our radii and just do as we're told. We will divide them. And then instead of adding, we're going to subtract our angles. And of course, we can't have the Z2 being 0. We really wouldn't care anyway, would we? So there's going to be two different rules that we have. So we have an addition. We have a product and we have a quotient. Where when we do a product, we add our angles. And when we do a quotient or when we divide, we're going to subtract our angles. It's not that bad. It's really not that bad. Let's do one. Let's see if we can't do one here. What do we got? So let's say Z1 is equal to 2 times, and let's call it cosine of 30 degrees plus I sine of 30 degrees. I think the notation makes it worse. And then we'll make Z2. Let's keep this mellow. We'll call it 3 times. And I don't know. Let's just keep it all in the first quadrant for the first time. All right, so we have a Z1 and a Z2. We're going to want to multiply them together, and then we'll do a quick little division on it as well. Okay. So let's look at it. We say, all right, so what's Z1 times Z2? And all we're going to do, we say, all right, take your radii and multiply them together. So it's 2 times that 3 on the outside. Cool. Then we're going to have cosine of plus I sine of. And since we are multiplying, we're going to take our angles and we're going to add them. So 30 plus 30 plus, and then we're just going to take the angle from our Z2, 60. And then we want to clean it up. And this is going to clean up quite a bit. But hold on, this is going to be 6 times, and this is cosine of 90 degrees plus I sine of 90 degrees. Cool. There it is. We put it together. We found our first complex number times our second complex number. And that is a good answer. Who knows, maybe on a test I would ask you to multiply 2 of them together and then leave your answer in the form of a plus bi. Maybe it'd ask you to do something like that, so it would leave you with 6 times, and that would be 0 plus 1i. You bring it in and be like, this is just equal to 6i. Who knows, maybe it asks you to do something like that, leaving an a plus bi, knowing how to go back and forth, combining a couple of problems together. Well, shoot, if we can multiply them together, we sure as heck can divide them too. So let's do it. So Z1 over Z2. So we're going to take that. It's going to be 2 over 3, right? 2 over our 3. And now we're going to write it down and be like, all right, so cosine of the first, which is 30 degrees, minus our second, which is 60 degrees, plus I sine of right the same dang thing in there. We're not going to keep it between 0 and 2 pi. We don't give a crap. We just want to see it work. So you get 2/3 times cosine of negative 30 degrees plus I sine of negative 30 degrees. And that, my friends, is how you would go through and do a division. There's not much to it. As long as you got the formula down and you've done them a few times, it works out the same way. It's the same process. It's not a very complex game. Sorry about that. So there's your basics. That's 4-3. That's what you're doing. You're multiplying and dividing, and then when we come back for 4-5, we're going to start raising them to powers and finding out like what's this raised to the 5th power. Maybe some quick tricks that we can use to get right through these problems. We might learn that the square root of 1 or the cube root of 1 might actually have 3 distinct answers that you didn't know about. All right. Well, that's it. I'll see you in 4-4.